So this is an example of an extremely crude UART decoder. I just whipped up an Arduino to decode the UART coming out of this openCam for the data distance of an April tag we're using. Right now I'm sending 1 and receiving 1. I can change this to any number below about 65,000 and it will still work. So this is what 62,378 looks like when transmitted using that command on the openCam, the hex UART. The Arduino code I used uses captures 4 characters. Each one of these blue rectangles is a sample, and the gaps here are full of 8 samples. I've just removed them so you can see the underlying code. They all look like this 4th character right here. This code is about as crude as it can be. I declare 32 variables. I check to see if there's this 5-bit low point right here, and if there is, I basically know the time of every other data bit I need for the rest of the statement. And then I go through and use these while statements to capture each bit 1 through 32. Yeah, there were a lot in here. Now when the UART transmits, here's the 5 zeros it sends to say, hello, I'm starting a transmission. And all of the code in the beginning up to here is the same every time until there's a 0, a 1, and this 1 0 means it's about to transmit. And then it has 4 data bits if it's in binary, and if it's sending a number over 10, it sends a ASCII character in binary. So if I send BB8, for example, it's a hex value. We have all the stuff over here that's always the same, and then we have a 1 0, and then we have B and ASCII, I mean binary, but the binary number correlates to ASCII. We have these bits out here which denote it's in hex, but now 8's binary, 0 0 0 1, so now that's a hex. So the code captures all of these bits. This is a 3-character message, but the code can go up to 4 characters and has to determine whether it's binary or ASCII, and then convert them from hexadecimal back into base 10 for an output. Here's an example of a 4-character number with only binary. Oh no, there's an ASCII character. You see binary, 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 but then the binary number is an ASCII character that you need to convert back. Right now this is receiving 533 bits a second, so it's pretty slow. And this is the part of the code that looks at the binary or ASCII and converts it out. You see here, if it's 97, 98, 99, 100, then we know that A, for example, is 10 in hexadecimal, or F is 15 in hexadecimal. And we get this from the binary calculation up here for the bits. And we do this for each character, so we know the value of each character. And then down here, we get our final number, and the way you convert back to base 10 is you take the last bit, it's flipped, and then the 3rd character times 16, the 2nd character times 256, and the 1st character times 4,196, or 16 cubed. The code here just tells the Arduino to ignore bits. Basically, if I send a 3-character value, it doesn't want to read the 4th character because it will see a bunch of 1s. So I say ignore that, ignore those 1s if I think bits 5 and 7 are high, or 29, 31, etc., etc. And it works for all the values up to, what did I say, 65K? And it prints the num down here. So this is certainly, actually, I'm pretty sure the most possible crude method you could possibly have to short of watching an LED turn on and off and writing it down on a piece of paper to decode a message from this camera. But I couldn't find any other libraries online, and I thought it'd be a fun learning exercise, which it was. It was a great pleasure reading the bits off this, changing one, seeing which one changed, and doing that over time, and then understanding what kind of message it was sending, decoding it. Really like code breaking, very fun. So if I send a 1, you can see we're only using the 1st character. We don't need the other 3. And these are all full of samples too. You don't see them. And the startup code is all the same. And then we have a 1 and a 0. And then we have 4 data bits. And you can see the 1 bit is lit up. So it's a 1. And it's 1, 0, 0, 0. It's indicative of this drop pattern. 1, 0, and there's our data bit that I read, and then zeros all across. If I change this to 6, we should see 0, 1, 1, 0, because 2 plus 4 equals 6 binary. And if we come over here to our code, that's exactly what we see. So we have this distinguishable, we have the 1, the 0, so we're about to transmit data bits, and then we have a 0 in the 1's place, 1, 1 for 2 and 4, and then a 0 in the 8's place, which is precisely what we see. And every single one of these bits are sampled. I'm only doing the blue rectangle for the start and end, so you can see the inside stuff. So I hope that's useful. And I'll show you the code for the camera and the code for the Arduino, and I'll scroll through it, because YouTube is really bad at putting code online. That's the April tag we track. A lot of this code we found online. This is just to track the April tag, find the theta and the distance, do some math. It's a really cool camera. We have an if statement, if stuff works out, and we come down to our variables. B and A is distance and theta, and then we write that to the UART. The Arduino code's pretty crude. I declare some timing variables up here. The test pin is the output for the blue rectangle, so I can see when stuff's on and off. We have our bits, all 32 of them, and then our trig, which is pin 4. If pin 4 is set high, that's our sense pin, and our data in pin. And if it's there for a while, it will turn on. And once it's on, and I know I'm getting data, I go into these little while statements. For each one's a bit sample. Now, ideally, I want to come back and do this so it automatically varies the time of each kind of sample over time, so I don't need to do 32 while statements. No one wants to do 32 while statements. No. Just goes on and on. And finally, then we do math to figure out what number we have from the 32 bits we've captured, and convert from ASCII, binary, etc. And select and print a number out. So, pretty crude, inefficient, probably a waste of time, but very fun, very fun. Anyways, hope someone enjoyed this. GG.